In homework part 4, question 1, we're going to learn about how banks create money through bank lending. Here, the reserve required ratio is 10%. So what that means is down here in this bank's T account, the bank has to hold 10% of its demand deposits on reserve by law. So 10% of 55.9 is 5.59. Now, the thing about a T account is the left or the right hand side has to add up and equal the left hand side. So to get this value here, we have to add these two together, and I do that in the spreadsheet over here. Equal sum. We get 372.95. I'm going to copy that over to Mob and Math, and then I'm going to copy it here too because both sides again have to be equal. I'm going to hit enter, and we only have one thing left to do here. Now this plus that plus these three items has to sum up to this, so we can calculate that over here pretty easily. I'm going to type equal that, and I'm going to type equal 0.1 times checkable deposits at the bank. And then the best way to do this is to take this total here and then subtract off that value, this value, that value, and that value, and then hit enter. Now I can double check to see if the left hand side equals the right hand side, and it does. So excess reserves must be 85.49 million, or whatever the units are. Okay. Now what that means is, let me go ahead and enter. So it's a green check box, green box. What that means, what this account means is, so this is the money that the bank could lend out, but can't by law because it has to have some money on reserve, some money from checking accounts on reserve just in case somebody comes in and wants to close out their accounts, right? Excess reserves are monies that the bank could lend out but doesn't because maybe they fear a bank run. Maybe because excess reserves are so large here, it's the third highest item on the asset side of the ledger. Maybe the reason why it's so high is because maybe the bank feels like we're going into a recession. When we go into a recession, people tend to, unemployment goes up. Maybe people pull money out of the bank, and so the bank has to be protected against bank runs, so they're holding excess reserves. Another possible explanation of why the excess reserves are so high is that post-2008 financial crisis, the Federal Reserve began paying banks interest on reserves that they held at the Fed. So instead of making loans to people wanting to buy cars, homes, or to the government via treasury bonds, this bank is making $85.49 million in loans to the Federal Reserve System, or their central bank. Okay? Okay, if you remember from the notes or our class discussion, in the simple multiple deposit creation model, banks do not hold excess reserves. The excess reserves ratio is 0. And no one is holding currency, so the currency ratio is 0. Now suppose Fred deposits $1,845 he found buried in his backyard. At the moment Fred finds the money, it starts to circulate. It's in his wallet, and he can use it to buy goods and services. Whoops, I put that in the wrong spot. This is the money supply. The money supply increases by $1,845. Sorry about that. Okay, now, because Fred's bank must hold remember, Fred's bank must hold a portion of this deposit on reserve. So 1845. I'm going to multiply the 1845 times 10%. Okay, so Fred's bank must hold $184.50 of his deposit reserve. Now his bank can lend out this difference, right? His bank can lend out this difference, and that equals $1,660.50. And maybe they lend it to Joan or Jill. At the moment, Jill's loan amount is deposited into her account. So when she takes out a loan, the bank will give her a check or just wire the money to her bank, and that money is sitting in her account, right? At the moment Jill's loan amount is deposited into her account, the money supply increases by that amount, $1,660.50. Okay, now Jill's bank must hold, again, 10% by law, right? Her bank must hold this amount of money by law, 10% of how much the money supply increased. Okay? Her bank can lend out the difference. Right? Her bank can lend out the difference of $1,484.45. At the moment George's loan amount is deposited in the account, his account, right? He's taking out this loan, maybe for personal items, and as soon as the loan's approved, he's handed a check, and then he might deposit the check into his account. The money supply increases by that same amount. Okay. Now George's bank, after this deposit is made, must hold 10%. Let me round that using Excel. So George's bank must hold $149.45. His bank can lend Jane the difference, right? They can make Jane a loan up to this difference, right? And then at the moment Jane's loan amount is deposited into her account, the money supply increases by the amount of that deposit. Okay. Now, letting money into existence continues infinite many rounds until demand deposits exactly equals what? Well, let's go ahead and just drag this down. And what I'm going to do is I'm going to pull this down until... We'll pull it down for like 70 or so iterations. Well, we'll drag it down until the pennies go to 0. Okay, so we got 0 down here, right? So this first column is how much money must be held on reserve, right? And this is how much the money supply increased by. Okay, let's go ahead and drag it down until the first column 0. There we go. Let's go ahead and sum up this first column. Okay, hit enter, and we change the decimal places, and it looks like it's the amount of the original deposit times 10. So the original deposit was $1,845. It looks like the money supply increases by that times 10. Okay, now the question is, why does the money supply increase by a factor of 10 here? Well, we have to go back to the notes to figure that out, right? Let me fast forward to the notes here. Oop, I'm in the wrong set of notes. Hang on. Here's the notes for part 4 of our class. If you notice down here, the change in demand deposits, so the change in money, equals 10 times change in reserves. And if you remember, that comes from, we derived it over on the next slide here. Okay, so if the change in demand deposits was 100 instead, then this 0.9 comes from the fact that the bank can lend out 90% of that $100 in new money, and has to keep 10% on reserve. So we do this off into infinity, and we get change in demand deposits equals 100 times the sum of 0.9 raised to the ith power here. And when we apply a little calculus to this, we get 1 over 1 minus 0.9. And that 1 over 0.9 is the reserve requirement ratio of 10%. So the simple money multiplier is 1 over the reserve required ratio. So 1 divided by 0.1 here is 10. Okay, so that's why the multiplier here is 10. If the multiplier had been, if the reserve requirement ratio had been 20% instead, I can change this to 0.2, and then I can pull this all the way down to the bottom here. And then I'll change this to just a number with 2 decimal places. And the sum of this is what? Okay, so the sum is that. What is 1 divided by the reserve required ratio of 0.2? 5. So if I multiply this very first number times 5, what do I get? That sum, right? So yeah, that's the sum. Okay. So the simple money multiplier is 1 over the required reserves ratio. And that's why you multiply that original amount of new money found by 10. Okay. So this is just 10. The simple money multiplier implies the money supply, let me type that in, increases by 10 when the Caucasian Central Bank increases quantity of reserves by $1. Let's go ahead and enter. Okay. And that's because the reserve required ratio is 10%. Now, if the currency ratio is 0.01 and the excess reserves ratio is 0.1, we got to calculate a new money multiplier. So let's go back to the notes and see how to do that. So remember, in the notes we derived the money multiplier with currency, excess reserves, all that. Okay, so this coefficient here is the money multiplier. And remember, if in our original situation where the currency ratio was 0 and the excess reserves ratio was 0, that's just currency ratio, right? So the currency ratio is 0, and because people aren't holding currency and the banks aren't holding excess reserves, the multiplier is just 1 over the reserve required ratio, right? But if the currency ratio is 0.1 and the excess reserves ratio is 0.1, then we have a different multiplier, right? We have a different multiplier. Let me put this on the side here. So the excess reserves ratio and the currency ratio, one's 0.1 and the currency ratio is 0.01. Let's go over to Excel here and calculate it then. So the currency ratio is 0.01, the excess reserves ratio is 0.1, and the required reserves ratio is 0.1. This is set by law, and these are kind of set by actors in the market, right? So let's go ahead and calculate the coefficient of this equation in our notes, which is the money multiplier. So it's the currency ratio plus 1, that sum in parentheses, divided by the denominator sum. And it is the reserve required ratio plus excess reserves ratio plus the currency ratio. So this is the required reserves ratio, this is the excess reserves ratio, and this is the currency ratio. We hit enter, we get 4.81. Yep. Copy. Let me set the notes aside. Okay. The money multiplier implies the money supply increases by this amount, 481, when the Caucasian Central Bank increased the quantity of reserves of its banks by 1. Let's go ahead and enter and see if we got the correct answers. And we did, okay? Now we're going to move into the money supply money demand model that we introduced a while ago. Okay, and we're going to see how this all works. So here's our original quantity of money, 7.61. This is the demand for money. We know it's the demand for money because it's downward sloping in the price of money, which is the nominal rate of interest, and the quantity of money. So the demand for money is the negative relationship between nominal interest rates and the quantity of money. So we got to calculate the original equilibrium, right? Okay, so the original equilibrium looks like the quantity is easy, right? Because this is a vertical line. The supply of money is a vertical line. So at this intersection, the money is the money, right? So the quantity of money here is 7.61. Okay, and then what we have to do is we have to plug this quantity of money into this equation. So I'm going to go ahead and copy this. I'm going to copy it up to here. I'm going to paste it over here into Excel. I'm going to multiply it by 7.61. And then I got to change this long dash into a subtraction symbol, a shorter dash. So the interest rate is almost 4, right? The interest rate's almost 4. Okay. Now I'm going to go ahead and label the graph. I'll change the color to black. So this is the money supply. This is money demand. The equilibrium is right here. And then the nominal rate of interest at equilibrium is just below 4. 3.96. This axis is the price of money or the nominal rate of interest. And this is the M axis, the quantity of money. Okay, that's how you would label that. And of course, the equilibrium quantity is just whatever the vertical value was on the supply curve. 7.61. Okay, that's how you graph it. We're going to close that out and clear it. So the nominal rate of interest is the opportunity cost of holding money because I want to choose a letter below. Well, let's just remember what the nominal rate of interest is. Nominal rate of interest is the real rate of interest plus expected inflation, right? Okay, it is the difference between the real rate of interest and expected inflation. It's not the difference, it's the sum. So that's not correct. Interest payments are foregone on money that is held. So if you hold money, you're foregoing the opportunity of earning interest. So B looks good. And then inflation reduces the value of the money that is held. Yeah, so if you're holding money, just think about this. If you're holding money and inflation is, say, 10%, or say 100%, what happens over the course of a year? What happens to the prices of things? Well, if you hold that money for a year, what's that money worth at the end of the year, right? Well, prices have gone up 100%. So over here in Excel, if something costs $25 at the beginning of the year and the inflation is 100%, 1 plus the inflation rate, which is 1.00, right, percent. Whoop, we'll just leave it as that. Or actually, we could write it as 100%. 100%. What happened to the price? The price went up to $50. So if you were able to buy one of those, let's say you could buy two of them at $25. So if you're buying two at $25, you have to hold $25 in your wallet to buy two of those, right? Well, in a year, that $25 that's in your wallet is still $25, right? You can only buy half as much. So you lose half your money. You lose half the value of your money if you hold that money in your wallet instead of into an interest-bearing account that accounts for inflation. So I would say B and C. So G. Okay. An increase in the nominal interest rate, right? What does that do? Increase in the nominal interest rate. Well, if the interest rate increases, let's go to our diagram here. If the nominal rate of interest increases, then we're moving up the demand curve, aren't we? Right? And if we move up a demand curve, what's happening to the quantity of money? The quantity of money is decreasing, right? And then, of course, the nominal rate of interest is increasing, correct? Okay, so the quantity of money decreased. So it does decrease the quantity of money held along the demand curve. So yeah, I'd say B is correct. And I would say this would be true if this was increasing. Okay. Increases the real rate of interest. So remember ceteris paribus, the Fisher effect. So if we hold this constant and the nominal rate of interest rises, then for this equation to hold, that has to rise too. Okay. So I'd say B and C are correct. The money demand curve does not shift. We have a movement along money demand. So the money demand doesn't shift. So anywhere it says money, and money supply doesn't shift. So I'd say B and C, J. Good, this one down here, after 3.5% economic growth, we get a new money demand equation, right? We have a new money demand equation. And it represents an increase in money demand because when you graph it next to the original money demand, it's to the right. So the money demand equation shifts to the right when GDP is growing. And the reason why that is because if GDP is growing pretty robustly, then maybe people are getting raises and they have more disposable income and they have more money in their checking account. And so when their paychecks are deposited directly into their checking account and they're getting pay raises, then all of a sudden they have their checking account swell, and checking accounts are part of M1. Okay, so now we got to calculate the new interest rate. So all I'm going to do is go over to Excel. This was the original intercept of demand, right? Demand's intercept was 10.2, right? The slope was negative 0.82, and money supply was 7.61. Well, the money supply is assumed to be constant. It's a parallel shift out, so the slope doesn't change. The only thing that's changing is the intercept of this demand curve. So I'm going to replace 10.2 with the new value. And I get 4.94 as the new interest rate. Okay. And we need to graph that. Okay. So let's go ahead and graph it. So money demand, not today, but in one period from today, right? The new equilibrium almost at 5, 4.94, right? Then we got to graph the original situation. So here's money supply. Let me just erase that and start over. Here's the original money demand. At time t. Here's the original equilibrium. And it was just under 4, wasn't it? This is the price of money, the interest rate. And this is the quantity of money, right? So that's how you'd graph it. And then interest rates rose here, right? Okay. So let's close that out. Now down here, suppose the inflation rate rises to 8.2%, right? This results in a new money demand equation, the blue one down here, right? So we got 12.36 minus 0.82 times M. The interest rates are even higher. So all I have to do to calculate this new interest rate is change the intercept from 11.18 to minus 12.36. Let me go ahead and delete all this stuff here too. So all I'm doing here is I'm plugging in the quantity of money, 7.61, into this new money demand equation. The 7.61 is constant. The slope is constant. The only thing that's changing is the intercept. And that raises the interest rate to 6.12. So now we've got to graph it again. Okay, so this is money demand, not today, but in one period. This was the original equilibrium. And it was just under 5, right? Just under 5. The new equilibrium is up here at a higher interest rate. 6.12. Right? And this is the money demand, not today, not in a period, but in 2 periods from today. Okay? And then, of course, we have the original money supply, and then 7.61. This is the price, and this is the quantity of money. Okay, that's how you graph that. So let's close that out. Now, explain why money demand is higher after ATMs, debit cards, and interest checking are introduced. Well, if we went from a society where there was no ATM machines, no debit cards, and there wasn't a thing called interest checking, then people wouldn't probably use a checking account as much. But once ATMs, debit cards, and interest checking are introduced into an economy, now all of a sudden people have more access to their checking account, right? So this tends to increase the demand for money. So at any given interest rate, people are going to want to hold more money because now they have an easier way to access it. Okay, so we end up with a higher demand curve, right? So I'm going to change the 12.36 from the blue demand equation to the 13.43 on the green demand curve, and we get an interest rate of 7.19. So we're higher on the supply curve, right? And instead of graphing, I'm just going to talk about it. So this is the original money supply. This is money demand in 2 periods. This is money demand in 3 periods. This is the equilibrium associated with that demand curve, and this is the equilibrium associated with the new demand curve. This is at 7.19. This height here was 6.12. So we're 6.12 here and 7.19 here. And then we draw dash lines over. Okay? Now down here, money demand decreases. So if consumers start using credit cards for most of their purchases, that means people don't have to hold as much money in their checking accounts. So that is usually associated with a decrease in demand. So this will usually result in lower interest rates. So let me copy this into Excel and recalculate the interest rate. So the interest rate falls as demand falls, 6.15. Okay, so now let's graph this. We got purple here. Where's purple? Right there. So we got the new equilibrium down here, right? So demand shifted inward, it decreased. Okay. All right, and then interest rates fell. So interest rates fell over here, right? Money supply is constant. So we have the original money supply, we have the original money demand, we have the new money demand for this particular model, we have the nominal rate of interest up here, and we have quantity of money down here. Okay, so you'd have to label this more completely than I did. Okay, down here, this is kind of cool. The Croatian Central Bank conducts an open market purchase of $0.56 billion. Using the multiplier from the end of Part B, compute the increase in the size of money supply, and then add this value to the value of money to this original value of money. So let's go back and get the original value of money. So the original equilibrium quantity of money was 7.61, right? So this is the original quantity of money, and we're going to add to it the increase in the quantity of money. Okay, so the way this kind of works is, let's go back to find what we're looking for here. Okay, so we need to know the change in money. We're going to multiply the change in money, or we're going to get the change in money by multiplying the money multiplier, not the simple money multiplier, but the money multiplier, times the change in reserves. So the change in reserves is this amount, 0.56 billion. So all we got to do is multiply the money multiplier. We're going to multiply the money multiplier by this 0.56. At the end of part B, we're up here, right? End of part B. Well, it should be A. End of A. I should change that. Okay, just change this to end of part A. Okay, so what's the money multiplier at the end of part A? Here's part A. The multiplier is 4.81. So I'm going to take this over to Excel. That's the multiplier. I'm going to multiply it by the increase in reserves, which is the size of the open market purchase. 0.56. Okay, that's the increase. The increase in the money supply. I'm going to add it to the 7.61. So I got the original money supply plus the increase in the money supply, which is from the money multiplier multiplied by the size of the increase in reserves, which is the open market purchase. So it looks like the new money supply is 10.3, and that makes sense right there, right? 10.3. Let's see if we got this right. I put it in the wrong spot. Notice that in my open math that this sum is correct because that sum equals 10.3. This right here is supposed to be the interest rate. So let's redo this. Hit enter again. Okay, so 10.3. Now we're out here at 10.3, right? We're out here at 10.3. So what we have to do now is we got to take this 10.3 and then we got to plug it into what? This value here is 10.3. We got to plug it into the purple equation for the purple demand curve, and we should get something just below 4. So the purple equation should be over here still. Whoops. Let's just copy it. We're going to plug this 10.3 into this purple demand equation, our latest demand curve for money. And we get 3.944, which looks about right here, right? Because we're just below 4. Hit enter and see if we got it right. Yeah, we got it right. So the interest rate fell when the Federal Reserve increased the quantity of money. Okay. Now part H, the situation is what? The Caucasian central bank lends money to its member banks at a lower rate than the market rate. And B, member banks know that the Caucasian central bank will lend them money to avert a financial crisis. Thus, Caucasian banks are what? They're not reserve constrained, right? If they're reserve constrained, then the reserve required ratio would be firm, right? And if you made a bunch of loans and you didn't meet the reserve requirement, the central bank could, bankrupt you, shut you down. Okay, so banks that lend money to consumers and firms that had been borrowed from the Caucasian central bank at a lower rate than the market rate is a form of arbitrage. So it's kind of a pass-through thing where you're really not doing anything to the product that you buy and then sell, right? Combine this with the fact that the Caucasian central bank will lend banks money to avert a financial crisis creates a moral hazard situation. Okay. Okay, due to the above issues, suppose the Caucasian banks lend out an additional $1.13 billion. So the money supply up here was 10.13 or 10.3. The banks, because of this arbitrage, they can profit from this arbitrage and the creation of this moral hazard. They can just simply lend a bunch of money out at, over $1 billion to people, and know that the central bank will bail them out if there's a crisis. So the money supply ends up increasing to this value. We'll hit enter to see what it is, or see if it's correct. Yeah, it's correct. So let's just get the correct value over here in Excel. Put an equal sign and then that. Okay, 11.43. All right. So the interest rate's now even lower, right? So the interest rate's now even lower. So it's down to about 3, right? So instead of using 10.3, I'm going to use 11.43. Remember, this is the purple demand equation. The purple demand equation has an intercept of 12.39, a slope of negative 0.82, and then we're going to multiply by this new quantity of money, 11.43, and we get something really close to 3. 3.02. Okay. And then hit enter. Whoop. Something went wrong. Okay, let's try using more decimal places. Didn't work. How about just knocking off the 7 there, truncating? See if that works. Whoop. That worked. Okay, so there's a round off issue somewhere. Maybe we rounded up too much in an earlier calculation and we were off just by a little bit. So the correct answer here is 3.01. Okay, now we need to graph this down here, right? So here's our new equilibrium. The interest rate is all the way down to 3.01%. Our nominal rate of interest, quantity of money, money demand, money supply, and our interest rate continued to fall. So it fell all the way down to 3.01. Okay, so it's something that looks like that. So we're going to close that out. Now down here is a little data project. I'm going to let you kind of try to figure it out on your own. But this is from the Federal Reserve Economic Database, better known as FRED. Federal Reserve Economic Database. And you just follow the instructions down here. Okay? And that's the end of money creation via bank lending.